All right, how's stream going? Now let's check. Well, Restream says quality is excellent, but can't see anything on Twitch, to be honest. Let's check again. All right, I can see it now. On YouTube. Oh, okay. See now. Okay, let's just adjust some things and let's start coding. Okay, starting. Okay. All right, that's good. Let's start. Right. Okay. Back to coding. All right, let's see. So, like the very basic functionality works now. Like you can press a button and it changes the display image. That's all cool. And while you're holding a button, you can show an effect. Like in my case, I'm showing a blurred version of the same image. I think when the button's pressed, it has to have some kind of brighter highlight, just, you know, as a feedback, because buttons on StreamDeck aren't really tactile, and I think it'd be nicer to see a feedback a little bit, at least a little bit visually. Okay, so I'm gonna do that. And for that, I'm gonna look up image proc crate to basically draw over an image. Okay, so let's grab it. And let's see what we can do with it. Let's see the docs. Okay, drawing basic shapes. That's good. Draw hollow rect. I mean, I think that's what we need. Okay, so canvas, like it needs some canvas. I think dynamic image can be, yeah, all instances of generic image. Okay, and okay, that's good. Okay, let's try this. Rest image, blur, whatever. Let's blur it. I mean, who cares, right? And then, like, can I just mutate it in place? I kind of don't have to. Yeah, let's see. Let's see kind of API this image proc has. Drawing. Full rect, mute. Okay, and can I? Yeah, it seems I can. And how can I get its bounds? Dimensions. It's gonna give me a rect. Well, it's not exactly a rect. Somehow it doesn't complain, but yeah, let's fill out everything. See pixel. Anyway, I think I do it like this. Nope. Let's see what this type is. Okay, the type pixel, that's great. Okay, it's in an image crate. Okay, what are the implementations? Okay, implementers, just color. Okay, RGB. Right? RGB. Does it look? RGB. Okay, but that's a little bit of a weird API. Okay, black and white. Okay. That's actually quite useful because I need exactly white, but how's it implemented? Oh my god. Just don't think any of these definitions make sense for me. Anyway, okay, that's not a big deal. I'll figure it out later. Okay, we need RGBA. Okay, let's give it RGBA. Okay, and as I said, we need rect, and instead we have just two numbers. Can we convert? Nope. Okay, rect. Let's look up the type. Ah, rect at of size. Okay, that's great. And for now the size is fixed. Expected 3, found 4. Welcome. Okay, canvas, rectangle and color. Canvas, rectangle, sure, yeah. That's what we don't need. Okay, so now image pressed should be an image with a border, right? Like 1 pixel border. But let's just see. I'm not even sure that the bottom right parts of this rectangle will be seen. There might be just a one-off error, but let's check. Yeah, exactly as I said. I can only see top. Oh no, I think, yeah, okay. I can see all the pixels, all right. But, yeah, I need to thicken the border, okay? Maybe I should disable scene switching for now. Yeah, that's what I'll do. So all of them should point to a scene called desktop. Okay. All right. So what have we got here? So we need to draw like a thicker rectangle. Okay, let's do that. For I in 0 to thickness. Thickness. By 32 equals 4. Okay. Let's actually, yeah, let's apply the suggestion. Okay, and of size 64 minus twice, yeah, twice I. Okay. Okay. But this, so this is I32, but this is U32. Okay. Well, okay, like in our case, U32 is enough, and that's kind of a more logical conversion. Like it's always going to be positive, the thickness. So the intent is more clear this way. Okay, yeah, I think that should work just fine. Yeah, it works. And I think we can add some brightness. Well, actually, like, we don't have to draw it like this. We can just overlay any kind of image over a button image, and like we can have any kind of effect we want, but like for now, let's leave it like this. And okay, it's blurred. I'd also like to adjust brightness, and let's adjust it by, say, 64. Like, I want a button to light up a little bit when you press it. Yep, that's exactly what happens. It's okay, that's good enough. All right, so there's one thing that I'd like to do that's a little bit more difficult. We need to get some feedback into this program, so that feedback from OBS. I want to check what scene is selected, and based on that, highlight other button. So but how do I do that? I think all of the services that this program, this app's gonna be using, I think all of them will be will have poll API. Yeah, I think it's only ever gonna be polling stuff. And it's not a big deal. So what I think we'll do, there should be another loop. Well, not another loop, because this loop, it borrows global state mutably. Yeah, so there are events like inputs from StreamDeck, and there should be events like changes coming from OBS, and they should be using like a single event loop. They should end up in the same event loop. If a button is pressed, that's one thing. We process an input event, and then let's actually see what happens. Yeah, so we process, that's an internal state. Yeah, and we feed this update event into a button. Okay, and then we update the images. Yeah, this code, it's just we have to run it first here and then here. So that's the only two places that this code is gonna be in. So I'm not gonna touch it right now. It's gonna remain the same, but here, yeah, we have to inject different kinds of events here. So let's do exactly that. First of all, let's just clean up our code a little bit, just so that it takes less space. This I don't need. Okay. So let's just make an enum enum event, and one variant would be StreamDeck, and we'll just StreamDeck. Let's see what's the type. StreamDeck input. All right, StreamDeck input. That's great. Another kind of event will be OBS, an event from OBS. Oh, for example, like when the connection to OBS fails, we should also be able to show it somehow on the deck that something's wrong with OBS itself, at least the WebSocket API. Okay, so OBS event, that would be another kind of event, maybe? Maybe just timer tick. Like, I don't want to overcomplicate this thing on one hand, but on another, like how many timer events will I be generating? For example, if we make a volume control that adjusts volume as you're holding the key, how many updates per second there should be? 10 maybe? Yeah, I don't think, yeah, but yeah, like, yeah, I still think like the precision and the granularity of this timer should be a little bit more than that. Maybe at least 10 milliseconds, and waking up 100 times per second, that's not ideal. So I don't think that I want to see any kind of periodic timer at such a high rate, like ticking at such a high rate, like 100 times per second. It's not a problem per se, but why would you do that? Like, it's not the best API. Anyway, we'll solve that issue when we get there. So OBS event, and what that would represent in our case, current scene changed, and it's great. Okay, we'll just identify our scene by a string. Okay, and global state will be okay, so I think we'll wrap our OBS client into kind of OBS state, and then we can run a pull function. Well, we're going to be running this pull function quite frequently too, maybe like 4 times a second or something close to it. Yeah, to check which scene is active. Anyway, it's okay. Let's do it. Yeah, let's just implement the functionality that I want right now, and let's think about that later. Global state with a client. Okay, let's just wrap this client into our own structure. And current scene is going to be a string. Okay, and yeah, there should be a method called change scene, I think. Yeah, I think we're gonna end up... Yeah, if we change the scene, we just replace the current scene with this value. I think it's a decent assumption. Yeah, let's do that. Scene name. It's a string here. Just pass it by value. Okay. Well, first of all, it's async. Okay, let's think about error handling later. It's nothing complicated, but still, let's implement the happy function path first. All right, so that would be self OBS scenes. Set current program. Yeah, set current program scene name. Okay. Wait. Well, let's just unwrap it. Should be good for now. Okay, so a str maybe? Okay. So it wanted a str. It didn't want a full like owned string. Okay, change scene. And another function? Let's call it poll for now. Okay. Poll and it should produce a stream of events. And I think it's time to think about channels. Yeah, so this is going to be a separate Tokyo loop, writing into a channel, just writing these events, StreamDeck, StreamDeck events into a channel, and there's going to be another loop. No, that can't be a loop, I think. Honestly, I think it can. Oh, okay, yeah. Well, does it handle concurrency internally? Okay, let's see. This one takes self. This one also takes self. Oh, and send message. What does it do? I think it locks a mutex somewhere internally. Yeah. Okay. That's... So, this library handles currency internally for us. I hope it uses Tokyo mutex. Yeah, it does. Okay, that's good. All right. So we kinda can use it concurrently. Yeah, I'm not sure it's a good decision on this library's part. Like this OBWS, obvious, how they call it, I think, library. So, yeah, not sure about this design decision, but it's okay. I'll roll with it. Let's pull. Okay, and when we change scene, we replace the current scene with the scene name. Okay, pull. Let's see what we can do. Scenes. Yeah, current program scene. And okay, there has to be some current program scene, and let's, okay, name is a string. Great. So, and if it's different, oh wait. Okay, so we can send an event, send a change event right away. Okay, anyway, let's events. Let's declare this end of a channel. So we're gonna be sending events from this OBS thingy, this kind of wrapper around the OBS client. Gonna be sending events, and it's gonna be a channel. Tokyo sync, yeah, it's gonna be MPSC sender, and what's the type of the event? Yeah, it's an event. Great. And let's just make a constructor right away. Current scene will be, yeah, let's just use an empty string, shall we? Is it a good idea? I mean, no, like, okay, it's never a good idea, right? Okay, let's just do it like this. Current scene is none. Right, why did I even think about it? Like, it was stupid. Sacrificing 1 byte to an API design and have a horrible API design. Yeah, that was just a really stupid thing to think about. All right, current scene. Scene name. Some scene name. Great. And send an event. Send an event. OBS. Scene changed. Okay. Clone it here and repeat it here. Okay. Do I need to wait this? Okay, why doesn't it complain then? Alright, I think it would have complained after I fixed all the errors. Okay, that's good. And new scene name, and if self current scene as ref isn't the same as some reference of new scene name, then get self current scene and unwrap here. Let's do the same thing. Okay. So now we can pull and it'll send an event when the scene is changed. But yeah, does it mean that all the buttons will listen to all the events? I think it does. Okay, so oh, okay, all right. So I think what we should do then is incorporate, like, all the buttons will be just processing an event, and we can process input events and OBS events exactly like in the same manner. Yeah, I think it's a good idea. So let's refactor our process update and like button input state. Yeah, but if a button doesn't need it, it doesn't need it, right? So I think our button state, like, my worry is that we need some larger button state. I don't think they're like correct. I mean, this larger state is even larger. So, and there's no intermediate, kind of no abstraction in between is needed. Okay, so process update. Old state will never need old state, and it's not going to be a state, it's going to be an event. But an input state, what kind of events do we have? Oh, we have a raw event. But wait, no, I don't want to be sending raw events. No. Yeah, this loop, it'll be handling raw events locally, and it's only going to be sending these kind of processed events, whether a button was pressed, released, etc. So it's gonna be something like this. Global state. So that was the only error here. Yeah, so that's gonna be a loop. And let's just spawn it right now. Okay, async. Okay, we'll add some error handling later. Yeah, I think it'll work. So, and it's gonna be input loop, StreamDeck input loop, join handle, and we're gonna be awaiting this join handle. Okay, and there's going to be another loop, the OBS loop, OBS whole loop, just called OBS loop. Oh wait, we've moved global states. Can we move it here? I don't think so, because we're gonna need it here. That's alright, we'll just protect it with a mutex. Do we even... Does it have to be mute? Here, does it have to be mute? No? It doesn't. But in reality, I think it does. Yeah, we'll just protect it with our own mutex. Just the fact that at least OBS API is already protected by mutex internally. It's their design decision, and like we still need our own mutex to protect the state. Okay, so okay. Now global state is gonna be global state, and let me mute global state. It's an arc mutex. Okay, of it, Tokyo mutex. New York const new, who cares? Global state. Okay. And now we don't have to move it. Now, with little, like, newer Rust versions, I think. Yeah, I think new Rust versions allow you to kind of avoid cloning this arc. No, but we can't avoid cloning this arc, right? Yeah, like at least here. Okay, so let's just wrap it like this. And it's global state, global state, and now, yeah, sure. And now it's our own global state here, and can... Yeah, we can lock it. And... Oh, wait. Yeah, sure. But as mute, deref mute, what is it called? Yeah, deref mute. Okay, so here's the input loop. Now our OBS loop, it's not, it doesn't have to be mute. An OBS loop is going to be very simple. It's going to be polling this OBS structure we have. By the way, let's use this OBS thing. So state, yeah, state will be this thing, OBS, all right? And when switch scene, oh, we have a mute, aren't we? Wait. Oh, wait. Yeah, sure. It's okay. So. Okay, scene. Yeah, to own. Okay, that's not a problem. But we still need a string. To save the current as a current scene. The precedence. Okay. Switch scene, but like this actual switch. Wait a bit. Oh, okay. All right, sure. Like this mutex, second mutex, it's internal to this thing. So we can't do anything about it. The events TX, and let's make a channel. Almost forget which one comes first, TX or RX, but I'll find out soon. ESC channel, yeah, TXRX, great. I think I need an unbound channel. No? Wow, I'm not a C# developer. Okay, let's just give it some channel. 32 events. Okay. We're still not receiving events, but that's okay. And here can do the same thing. So it's going to be a loop. Global state, PS poll. Oh, yeah, that's good. then just Tokyo time. Just 4 times a second. Okay, that's good. All right, so, and let's join on this loop too. Well, we can actually select like whichever quits first, whichever receives an error. Okay, so got the syntax. Is it Tokyo select, right? Yeah. Yeah. So we don't care about the results. In fact, they return. Well, in this particular case, we really shouldn't be doing that. Oh no, we do care about the results. There's an error, right? Okay. So if it exits with an error, it's going to be a Tokyo error, executor error, because the actual return type is empty, at least for now. Would not return errors. Okay, so input loops are ready. Now something has to be processed in it, those events, right? Yeah, let's make an event loop. I'll extract everything into functions later. Event loop. Does it need global state? I think it does. Okay, so an event loop, what is it gonna do? Where's our old event loop? Oh, this one, right? Yeah. Yeah, this one. It's just now never received this. Process to iter. Yeah. So here we need to be sending events to this events tx. Oh, by the way, we need to copy a tx too. But for now, let's just send it here. And we'll be sending a state change. Why not? Right? Do we? No. I think... Yeah, I think it's more generic. Let's send the whole state change. And so it's going to be StreamDeck input, but state change. Q8. And what is it there? button input states. Okay. So just like this. And then this part of the code yeah, okay, so then what will happen is that yeah, we'll send this event to the button itself, right? And then yeah, so button events only go to, yeah, but why? Yeah, I think all buttons can process all the events, like it's StreamDeck. How many buttons do they have? It's not a problem at all. Yeah, so every button is gonna process all the events. It's not a problem. So we send the event here, and this will go somewhere else too. And then here we listen while some events are X. Why is everything red? Okay, how did I break everything? Okay, and while the API goes like this. Yep. Okay. Oh, this one has to be mutable. Okay, and this can't move events tx. Yeah, because it needs its own copy. Oh, okay. We don't need to clone here then. Okay. Now we receive all the events and just based on the type, we're gonna do slightly different things, I think. No? Will we? Do we make... Yeah, let's do that. Let's actually do that. So the button will know its own index. So it'll be able to filter events. It'll be also listening for all the events for all the other buttons. Yeah, I think it's okay. Like, we'll be broadcasting all the events. Okay, so this process update then needs to change. We're still gonna be, yeah, this I'll fix later, but for now, this new state is gonna go. First of all, button. It needs to know its own index. Okay. It knows about its own index, and so it's not going to be a new state. It's going to be, oh, it's just going to be an event, right? So that's okay. That's just going to be an event. Going to be doing that. And okay, so let's now specialize this button. It's gonna know what scene it's attached to. No, I don't think so. So there's gonna be action, and so action switch scene, and also some yeah, it's just not going to be only an action, it's also going to be a listener. So it's like more like a role or a function, kind. I think it's action. Let's call it action for now, but the thing with it is that, okay, switch scene. No, yeah, it's gonna be this should be a trait, and I think it's exactly the place where a dyn reference makes sense. Okay, it's not going to be an action, but we'll come up with a proper name later. So, and oh, okay, invoke is just a reaction to a key press event. Great. Yeah, so it's just process event. So it's kind of not an action, but a reaction. Also, it's kind of an actor. Okay, so async of an process event. Is it self or mute self? I think it should be a mute self. Yeah, definitely it should be a mute self. Wait a little bit. Yeah, I think... Yeah, that's what... Okay. Enough with that. We'll hardcode the switch scene into a button and just rename button into a scene switcher. Okay, and it's gonna have kind of the same process update interface. All right, let's just do it right now. Scene switcher. And yeah, that's good enough. I think the API is good for this. All right, so now that we call it a scene switcher, this whole action stuff is like it's completely redundant. We just need the name of a scene, not an action. Like, okay, scene. Okay. Now like this. And scene. Great. So based on, yeah. Okay, that's great, magnificent. So now we'll just image dirty. Yeah, not every event is gonna invalidate the current image. So that's what we'll do. If it's an input event, okay, we're only gonna listen for messages for events regarding this button. Okay, and OBS event, I'm only gonna be interested in scene changed. And the rest we'll just ignore. So change, new state, rest. Okay, self-rest. And let's move it here. And instead of this action invoke, we don't need it anymore. We'll just, yeah, and that's why we need state here. Yeah, that's good. So good thing I didn't refactor this, at least for now. Scene name, change scene, self, scene. Oh, wait. Okay. Okay, image 30. And we're going to receive this event right away, because the OBS, this change scene, is going to send this event back, the scene changed, so it's the next thing that we'll receive. Okay, and so so which image to display? Okay, that's the question. Scene switcher, and yeah, we'll have 4 possible images. Normal, pressed, current, and current pressed. Okay, inactive, yeah. Inactive pressed, and active pressed. Okay, and let's just implement these right away. And active image. Just original, just an image, okay? And so image, it's gonna be active pressed. Blur. Okay, inactive will be image. Well, actually, I think inactive will be just the original image, right? And active will have a border. And pressed will be blurred and brightened. Okay, so that's it. And let's active pressed be the same as active. Pressed. Yeah, okay, that's good. Wait, active. It's okay that we blur the border in. Yeah, okay, inactive and inactive pressed is gonna be like this, okay? Now scene, search images. That's just images. Yeah, okay. So, and which one is selected? Yeah, current state, activity, and is it being pressed? And the current state then will be, I think by default, inactive and not pressed. Okay, and whether or not it's dirty. And we will set state. Active, boolean and pressed boolean, and and if those are different, then we set the dirty flag. Okay, and another check. Is dirty. It's gonna return the current status and reset flag. Okay, like this. Image pressed, now we don't need that. And we have all our images here. Okay, so that we, okay, image update. Oh, there's another thing we need. It's dirty. No, updated image. Okay. It's gonna be an option of dynamic image for now. So dirty here, dirty false, and if dirty, wow, it's actually quite a bit easier. If self-dirty, then self-dirty false, and return an image, match self state, turn self active. Self inactive pressed. Okay, like this, and yeah, I'm really not happy cloning images around, but this API kind of forces me to. They should be accepting not a dynamic image, but another thing that allows references like a slice, image slice, image view, it's called, I think, in this crate. But anyway, okay, some otherwise none, I think, right? Yeah. But I did clone. Oh, sure, yeah. Okay. Scene switcher images, and so that just becomes as easy as self images outdated image, right? Yeah, and self image dirty, don't need that. Don't need that. Great. And oh, that's actually neat. I think, yeah, those need to be separated because those come, like, information about these flags comes from different events. Self state equals active, but then we'll have to validate That's okay. Pressed. Okay. Yeah. And if scene changed, what do we do? Well, we check if, yeah, we update the active status. So basically self images. Why does it live in images though? Self. Yeah, like the state should be okay. If I stop calling it images and start calling it state. Yeah, somehow it incorporates an image. Yeah, but this we don't need anymore. So, yeah, okay. It's not images. I'll refactor this afterwards. Oh, let's roll for now. Yeah, it has nothing to do with images. So what we do, we just inline it all back here. And the state, it's gonna be active, full, and rest. Ooh. Is active and is pressed. It's gonna be a dynamic image. Okay, that's good. We don't have any state anymore. Just fill it out. What we do? Why? Oh, okay. We're not supposed to. Yeah, it's empty now. Okay, and this just moves here, and it all looks better now. Yeah. Match self. Active self rest. Yeah, self is active, self is rest. Okay. State, we don't have no state.
Here we go.
Okay. So this is handled, right? Is it? Yeah. So, okay, active and pressed. Don't need this. Yeah, this anymore. Scene switcher. Okay, like this. Set active. Self is active. Okay. It's pressed. Okay, that's good. State, no, just like that. Alt pressed. Okay. So this is okay. So now, if yeah, so no, even yeah, even like this, set active, self scene equals scene, and that's it. Great. So now we only need to fix this. Now buttons do have to need to know their own indices, but yeah, no actions, which is fine. Just okay, and to test it properly, okay, how many? Oh, that should be an own string, right? And now this one's game, and this one's PRB. Okay, let's test it now. No, I don't think it'll work. Yeah. Okay, what's not implemented? Oh, right. An event loop. Oh, I don't even care about the... Yeah, I'll be just sync the event to all the buttons. And where are the buttons? Yeah, prepare them here, and go. Consider mute. What? Oh, this. Yeah, this. Yeah, it's an input loop. It has nothing to do with it, right? So let's move it here. So it's the only thing that does this kind of stuff. And it's gonna do it here. Every event you receive. Okay, that's good. Oh. Ooh. Async StreamDeck. So. Okay. Well, I think we'll just wrap it in the mutex. Let's call it StreamDeck, okay? Let's grab a mutex and do this thing. And inside. Okay, so we're going to be handling an event first. First, we send this event to all the buttons. Well, we'll call them widgets later, probably. For each button and buttons. I don't even care. Yeah, I don't care about their numbers at all. So this one, yeah, this one's not gonna be a hash map even. It doesn't need to be a hash map. Okay, it's just a vector. I don't need an index. Okay, I do. No? Do I? Well... Okay, for now, let's just use this index field. I'll deal with it later. So, button index. Okay, for every button, we're just gonna pass it this event. Okay, yeah. Yeah, so we'll grab global state here. Oops, okay. And then will we need global state here? No? Okay, then let's just do it like this. Every button. StreamDeck. Yeah, I think we need to basically, yeah, we're not going to be holding this mutex for a long time. Let's just lock it here. Okay. Now what? Okay, this needs to be mute. And the event. It's already moved. Where exactly? I don't quite see where I'm using it. In a previous iteration of a loop? Excuse me? Okay, let's deal with this. Okay. I see, probably. Oh. First of all, right? Well, it's being used somewhere else already. Okay. StreamDeck. Okay. But what about the event? That's the weird one. Ah, sure. Yeah, okay. Oh, wait. Okay. Oh, well, actually, what am I doing? Let's just change the signature. Doesn't need to receive an event by value. Okay, put an input. Will the lifetimes be okay though? We'll see. Okay, they are. Let's search for to-dos. Nope. Anything unused? Right. Okay, event loop. Okay. Okay, for now I'm just going to be unwrapping up everything. We don't need global state here at all. Okay, that's good. Good to know. Okay, so actions should go. Okay, this is okay. I'm gonna leave it for now. So, anything else? Yeah, that's all. Okay. Let's run it then. Something's not right. Yeah, we'll need to debug it. Okay, so that's interesting. So what's wrong here? Process update, and then we update all the images. Oh, let's do that. Okay. Okay, that's interesting. So we're not using, yeah, we're only using Tokyo's Redux. Okay. Well, right. Let's see what locks we acquire and for how long. Yeah. So yeah, we'll wait for the next input. Yeah, it's a kind of weird the weird API they have here. Okay. So I'm holding a lock for the whole StreamDeck here, like forever. And then the event processing loop that tries to update an image, like it basically fails. Well, it's waiting forever then, and the whole event loop stops. why do we need a pull rate? Like, can't we just pull it once? Yeah, that's a little bit stupid, to be honest. So, like, if you want to update anything, yeah. Okay, so I think I need to use a synchronous version of this API. Maybe, like, do I have another library? Because this one, can't say I like it. Maybe this one? Oh. I don't know if this one's better or worse. Let's see the API. Is it the same, like, the same library? Okay. So, yeah, I think need to use synchronous API. That's not a big deal. Okay, so there's just gonna be a handler for the StreamDeck. It's gonna be serving both the inputs and image updates. Okay. So it's gonna have inputs TX, Tokyo sync. Doesn't have to be an MPSC. Yeah, I'd rather say Broadcast isn't good. Okay, maybe watch. Yeah, let's use this one. Inputs, sender. It's gonna be sending. Vector of booleans. Let's call it raw inputs tx, and called images rx, even though it's gonna rename it sometime. That's MPSC receiver. I think it's, yeah, let's just make it an unbounded receiver of a, let's play U8 and dynamic image. That's it. Yeah. And the main loop will be, sync and run. The main loop okay, but it's not async, right? Or is it? Yeah, I think it is. Yeah, I'll just tell Tokyo that those code blocks are blocking. Okay, so oh, just a timeout. Okay, no need for select. Logo has already has a function, helper functions for timeouts. So in case of OK, it means that we've received an image, but it can still be an error, right? Oh no, it's not an error, but okay, let's handle this. Index and image. fill out this later. Oh, okay, so there might be an error as in error, an actual error, right? Oh yeah, lapsed. Oh yeah, sure, yeah, exactly. That's right. So, and if there is timeout, then we'll just pull the input. StreamDeck, let's move the StreamDeck client from here. Oh. StreamDeck. Oh. Alright, let's come up with a better name later. StreamDeck. Okay, so StreamDeck. So, what do we do here? We do all inputs, read input. What's this duration for timeout? That's interesting. What does a timeout mean? Is it a timeout or? Oh, sure it is. Yeah. Okay. Great. Timeout. All right. Wait. No. I don't need to timeout. Yeah, I don't need a timeout. So I think I'll only... Yeah, that's great. None. And let's unwrap now. StreamDeck input. For now, we only care about buttons. And we just send it right away to raw inputs tx. Send. We'll just send a new value, which is a bool, right? And the rest of the events we don't care about. Okay, and in this case, set button image, index image. Okay, and since it's async, Well, this one, to be honest, I assume it to be fast. Okay. We'll see. Okay, we'll see. Maybe we'll need a timeout, or maybe we'll need to they do it also kill that it's to kill. Okay. Cascade, I think. Block. Spawn blocking. Just block in place. Yeah, it's. Spawn blocking. Yeah, I'll just do. Oh no, I can't spawn blocking, right? Oh, can I? I think I can. Can I join in it? And what's the lifetime? Yeah, it's static. So I don't think. Yeah, I can't do this, but this I can do. Probably. Right? Can I? I don't think I can actually. Not like this. Okay, I'll be right back. All right, I'm back. Okay, so let's create a couple of channels. Inputs. I don't know why I decided to make it a watch channel. I think it should be just the same kind of stuff. Unbounded sender, like MPSC sender. Yeah, in my case, there's only gonna be one consumer anyway. Tokyo sync MPSC on the channel, right? And images TX, just RX. Let's make an unbounded channel too. Okay, StreamDeck loop. Let's create one. Raw inputs. TX images RX. And a StreamDeck. Okay, that's good. And we'll just run this loop as usual. Oh, maybe this I should have spawned as a blocking task. Yeah, I think that's better. That's much better. So instead of blocking in place here, yeah. Just gonna do this. Wait, no, okay. Yeah, all right. Nope, we'll just spawn it as a regular task because it needs timeouts. StreamDeck loop, right? What is it? No, StreamDeck loop dot run. Okay. Why didn't I need a structure for this? I don't know. But anyway, let's wait for it to. Okay, there's no StreamDeck anymore, but there's images. We need to lock anything. So images TX, send. Oh, okay, and same here. Okay, and we don't need to hold this. It's raw inputs RX, save. Let some buttons just new states. Yeah. That's definitely not needed. Okay, this needs to be mute. That's 2, I think. And this I don't need. Neither do I need this. Okay. This. What? Oh, come on, I'm joining on this handle. If I do this. No. Okay. All right, then let's do what? Yeah, I just don't need it. Just don't need a function. I mean, I don't need a structure. StreamDeck loop. No mute self. And just this. Okay. This. All right, and all these selves. Don't be so selfish, function. Okay. Images Rx has to be mutable. Great. I mean, the binding has to be mutable. And StreamDeck loop with these arguments. Great. Why? Okay. To unwrap it. I just can't see it. Oh, it's this one. Right. Will you? I did. All right, this off. Okay. Now, yeah, let's see what happens now. What, it exited? Okay. Scene changed. All right. Why did it, like, exit? No. Sure enough. Forgot the loop. Yeah, happens to the best of us. Right? Okay. So let's try this one. Okay, at least it's running. Current scene is desktop. Okay, great. So let's check. Great, so it works now. I can see the current scene now. Yeah, that's good. Okay, so I'm gonna be wrapping up, but last thing I'm gonna check is I'm gonna see if I can get a mic mute status. Okay, so OBS, where can we handle it? Well, in the OBS, yeah, in the OBS loop. And where do we pull? Okay, pull. Inputs. Yeah, I can, but yeah, I need an input ID. Alright. Like this. Maybe. Mic aux. Okay, and current scene and mic. Well, not only mic, like stream elements. Maybe I'd want to mute stream elements. Okay, for now, it's gonna be only mic. Mic on. By default, we don't know anything about it, and if it's muted, okay, just unwrap, I think, for now. Okay. Ooh, input ID. Okay, what is an input ID? Input name, inputs. Oh, actually, yeah, actually it wants Yeah, it wants an own string, but here, oh no, I mean like this. Okay, that works. All right, so I'm just gonna pull this and gonna add a method to set mic on or off. Inputs, set muted. And let's copy and paste it for now. Not a big deal. Set mic on. So now we can go ahead and make a dedicated button for mic. So that's going to be handy. That's going to be already better than the setup I have with the default Linux StreamDeck client. Scene switcher, and that's it. Button input, button display, date. Yeah, we don't need any of that basically, but I'll just copy. Well, it's going to be quite a bit simpler to use, to implement, I mean. Scene switcher. Okay. Mic switcher, an index, okay, scene, we don't need that, just need is on, muted, and live, and dirty. And that's it. Okay. But we'll need 2 images. Alright, mute it. Mute it and live. Okay. Don't need any of that. Let's assume it's on. It's much safer to assume it's on. Muted, live. Okay, that's good. And set. Okay, let's not on, but live. Okay. Live, and it's live. Okay, this I don't need. And updated image. If self is live, self live, clone, else self muted clone. right? So that makes sense. Image update, updated image. Yeah, whatever. Cool. I mean, probably just do that. And same there. Okay, and process update. Okay, alt still can be pressed as live. Alt is live. And set live. Oh, wait, no. It's about the pressed status, okay? Pressed status, we still need it. Switcher is pressed. It's a completely different thing. But at the same time, it was nice that I did this kind of blur thing, but is it useful? I think I'll do the same for the mic, actually. Okay. Yeah, I will. Muted live and muted pressed and live pressed and muted pressed will be muted, blurred, yeah, blurred and brightened. Okay, like this. And live pressed would be the same thing, but the live image. Okay, set live and alright, and let's bring this back. Where is it? Okay. It's live. So if it's not live, then it's going to be muted and muted pressed, and this one's going to be live and live. Okay, and let's bring back the set pressed. Okay, set pressed and mute mic. I mean set mic. Let's rename it to set mic live. Yeah, doesn't sound right. I think I'll just later rename it into mute and mic live. Right, but it's okay for now. Set mic live. Self South is live. Okay, South is live. We'll just invert it. Okay, it's good. And oh, we need to receive an event. Scene changed and mic. Changed scene. It's an event. Of course, it's changed. So in mic switcher, it's gonna be mic live self live. All right. Okay. Okay, that's funny. So now we need 2 more pictures. Or just red square. I mean, no, just a red circle and a gray circle. It's gonna be enough. Okay, why don't we use this function? Oh, because we don't have any. Oh, okay. Okay, now it's gonna be interesting. So these 2 traits, we're gonna join them into a single widget. Trait. Okay, pull widget. That's good. And that's good. And our buttons is going to be a vector of dyn widget. Oh. Yeah. Yeah. Asyncs are not object safe. Yeah, that's funny. But yeah, what do I do then? Well, okay. Anyway, it's gonna be vector of any widget, and any widget is gonna be trait. It's gonna be an enum. And it's either gonna be a scene switcher or it's gonna be a mic switcher. So, okay, that easy. And then I'm gonna implement widget for any widget. There are crates that automate this kind of pattern, but we call the name of the crate. And yeah, it's quite easy to implement it myself for now. Let's just forward these for now. Clean it up later. Like, I think I'll need to pull in this crate that automates this kind of pattern. Anyway, so now it's on any widget. Yeah, vector of any widget. It's going to be an any widget scene switcher. This. Okay. Yeah, still like this crate will auto implement an into, like a from and into for me. Okay, so an index, actually any widget. I only need an index when I do an image update. Right. So let's just simplify a couple of things here. Right. Okay. Self index. And same thing here. All right, so no need to do that anymore. Okay. Okay, that already looks good. Let's just add a mic switcher. And it's gonna be, what do I have here? So yeah, I have 15 buttons, some muted and live. Let's make some images. But how do I fill with a particular color? That's weird. Okay, anyway. So, right, it doesn't have method to fill. I don't know, okay. Resize to fill is okay, but how do I just fill? I convert. Okay, anyway. Maybe I need to import method. No? Alright, let's just do it like this. Walk. Right. Geometry is okay. Arc. No. Okay, drawing. Let's have a circle. Okay, draw filled circle. What's the difference between those two? Oh, okay, filled and hollow. All right. So canvas is muted. This image, and again, how do I? All right, center radius color. Oof. So it's gonna be slightly off center. Like what the hell? Okay. Okay, not a big problem. Imputed is gonna be RGBA. How do I just construct RGBA? Oh, okay. With an array. Okay, great. So imputed is gonna be gray, white 80. Actually, that's 80. And full alpha. Okay, and live is gonna be same but with red, right? Okay, let's try this. Yep. It actually works. Yeah, I mute myself. I unmute myself. So, escape. Cheap effects. Well, actually, I was pressing it quite frequently, like quite fast, and it was continuing to send the callbacks back. So we can try it once again. Yeah. Well, I'm actually not sure if it's a good thing or a bad thing, but at least for now, it works, and it works better than the setup that I had by default. So pretty happy about it. Not customizable at all, of course, like not even a configuration file, but yeah. It's looking good. Anyway, I think that's it. So yeah, that was some good result.